Okay, we should be live here. Hi. So today we are going to do a fair bit of experiment analysis. We are going to do probably some work on the blogs. Just going to be chill work day, working on a release. We'll see how the experiments have gone overnight, and we will probably start with launching some new ones. Pop out the chat real quick because I forgot to do that. One second. Chat. Cool. So we're going to start right here. Two sweeps. And on rel time here, this one, there we go, 17, 18 seconds. So we're sub 20. This is what we want to see. And this other sweep, I believe, is not. Yeah, so 23. So it's pretty interesting that just preventing this thing from doing multiple epochs has a pretty big effect. So I think that this means that probably our sensitivity for sweeping discrete variables is probably substantially too low. These both on the same machine. Actually, hang on, that's a good point. Let me go check what machines I launched these on, because I might have launched one on a faster machine than the other, which would be a bad mistake on my part. I don't know why I did email. We have this one. We have the obvious next logical experiment here. I think which machine I want to use for this. Do status real quick. So this is up to date. It'll also be up to date. On how to. Any specific reason why you picked Neptune over MLflow? I haven't tried MLflow. We support both 1B and Neptune. Is MLflow good? They have like almost the exact same landing page. That's funny. These all look like clones of each other. Is there anything that you like about this one specifically? So Neptune, I like their dashboard views for one. I like that I can just define a whole bunch of different plots here and then apply them to any experiment really easily. I also like their download API. The fact that they just give you all your data as a SQL table is really, really nice. So I don't use it that often. And it's also a max of 200 points per plot at the moment, and should be bigger in the future. Only thing I'm not sure about, actually, I think they replied to this. If I check here, I think they replied. Because there was a question about open source. Closed access for new version. So actually, I might be forced to ditch this anyways. Because they don't know if they're going to have an open source thing or not. So if I have to ditch it, I have to ditch it. It's kind of crazy for them to like 5x their pricing and delete their free tier if that's what they're going to do. Starting $250 a month is just dumb. So if they want to do that, they will they'll go bankrupt, but that's up to them. MLflow is it all open source then? Because all of these different companies have on-prem, but it's not actually open source and they charge you a ton for on-prem. Like that's their most expensive option. I do very much like Neptune's dashboards thing. It's also kind of ridiculous how many of these companies there are if you think about it, because like it's not a big market at all, right? Like you're basically like relying on a few orgs to just massively overpay you and then fund your company. But I don't know how the hell there's like in a space this small, there are like 4 or 5 different things. It's kind of ridiculous. And how none of them are actually nailing it. Like they all write this really shitty web code that's just way too slow. Last place I interned at, we had 2 to move from 1B because we got hit with downright ridiculous fees. Yeah. I mean, I want to have. It's tough because I think Wanbi is the biggest one right now, so I have to have integration with that for users. I was gonna do like Neptune as our default one actually because I think it's substantially better, but we'll have to see what they do with their next release. Like if they make it no free tier, and $250 a month pricing, then like even if I wanted to use it and would pay for it, I still can't have it be the default in Puffer because that's just downright stupid for an open source library, right? So we'll see if they do that or not. They have a good product. It makes sense to have the free tier, I think, for this, even if you like don't give a ton of data or like one project or whatever, because it'll be good for like individual use, which is all I need for open source tier, and then like it'll get bigger companies onto their platform because like people use Puffer, but that's up to them, right? I'm not going to endorse it at all in the future if they do it, so. Okay, so this is what I was doing here. I'm going to set the scale to be 2. And then I'm going to run this sweep again. NVIDIA drivers. There's so many like these little annoying tech quirks. It's just like, why does this stuff happen? Like, why does just Docker forget that I have a GPU? Driver library mismatch. This can't be. Why do the drivers just do this? I didn't update anything. It just randomly does this, really? I'll reboot the machine. Hey, Boxen. And we're waiting for this machine to reboot so I can launch a job. Container also Debian? No, we were doing, we've moved from Debian host and Ubuntu container to Ubuntu host Ubuntu container. Still working on pre-release, yep. It's mostly, we're doing experiments now, so we're trying to speed run breakout. We're trying to figure out like what's the fastest possible breakout solve. That's going to be like one of our demos. Because I want to do this thing basically where like, you know, I just grab PufferLib and then I just in one GIF, right? I train a model on breakout, I grab it and I evaluate it. As I said, I did a PR with changing the name. I will go double check. Do you have a trainable model yet? Like, do you have a model that does the env in a way that you're happy with, or no? Box is not coming back online yet. This is weird. Let me go double check with this box real quick. So, there's this really annoying thing with modern desktop computers, desktop motherboards. They don't turn on if you don't have a monitor plugged in. And I forgot to buy one of the dummy plugs that tricks it into thinking that there is one plugged in. So, oops. This should come back on in a second. We'll see. Nothing finds equilibrium. If you're still here, Boxen, I don't know, maybe make the problem simpler. You know, give it like a map with a bush and like 2 agents. Run a sweep. It's a tough problem. I think most humans fail that problem, so. Works like a charm. Dude, what the heck is wrong with, I don't understand. How did it uninstall my drivers? Like, how is that a thing? Makes no bloody sense that my server can be fine one evening, nothing changes, and then the morning, NVIDIA is just somehow not there. I don't have like auto whatever update on. Somehow some library is missing that wasn't missing yesterday. And now it works. Weird. GPU driver would not work. Well, this I did have to do that. Because this needs specifically 570 open. It says on the website, like, yep, you need 570. It'll, like, black screen won't boot from motherboard if you do that. It needs 570 open specifically. Somehow it uninstalled some library that it needed on the host, which makes no sense. But whatever. This is gonna fail because it needs my key. Nope, I forgot I put it in an end variable. We're good. Let's make sure that this actually finishes running. This should give us decent speed run. So it would have to do 60 million steps at 4 million SPS to get 15-second solve. Okay. We'll let that be. Okay, so breakout speed run probably will be in a decent enough spot. I think there are like a few more params we can sweep here and there. We'll get a couple more of these in per day. That's good. Let's look at the rest of stuff. I did a draft for protein yesterday. We have this box here that we can run. We can run extra stuff on as well. With this one here. Oops. Okay, so we did draft a protein. We haven't drafted new M's yet. That's going to be a lot of like assets. Algorithm improvements are pretty experiment heavy. Remaining questions. Okay, so we're answering this right now. Priority sweep. We could work in the other prioritized replay variables, right? The sweeps. Just have everything in the sweep, really. It shouldn't be an issue to have a ton of variables in the sweep, provided that they're continuous. I think continuous vars in sweep generally is pretty much fine. And I guess technically you need like more and more samples to rank. But I haven't seen any big issues yet. We can definitely do something about that. I think that that's probably what we should do today, is try to get some really killer maze sweep. Get like a baseline on maze, and then get some really killer maze sweep. Yeah, let's do that. Okay, so this is the crazy sweep here. Got rel time. And we gotta just go pick one of these things. Purple one is good. And I really wish there were an easier way to just click the damn thing that you want. Just add a filter, maybe. This one's not as good, actually, as the other ones. This is the one that's really quite good. 0.9. Like this one, maybe. LSTM question. What happens if the number of consecutive time steps per agent per batch is less than BPT horizon? So you have num-ems and effectively only get... it should break is what should happen. It should give you an error of some variety. And in fact, in the latest versions, I have an auto option. So like, let's say that you set num-ems and batch size, then it should auto-calc BPT horizon. Or if you set BPT horizon and ems, it should auto-calc batch size. So I'm trying to make robust ways to do this, but generally, what we've done with this update is we've given up a little bit of the flexibility of the previous batching system in order to enable all the advantage filtering stuff that we do now, but that has to operate on the level of trajectory segments. It's really worth it, though, from what we can see. Okay, so this is 90% on mazes. This is a very good policy. Big batch. Is this 250 mil? 55 mil. That's pretty good. One update epoch. Anything else? I think that's it. Cool. So this is a 3-minute run. 1.4 mil SPS for a 2.2 million parameter model is amazing. And we'll see if this does anything. We have this guy. No, this guy. Perf. There we go. Be right back. All this runs. I'm just merging latest dev. Did you delete demo.py? Yes. Use clean PufferLib the same way you would have used demo.py before. So this doesn't repro fully. We get 75. We don't get 90. Did I miss a parameter? So this does have some noise in it. But, yeah, not fully reproing is not great. I'm sure this is still a decent policy, right? Load model path. Wonder if it eventually gets out. Yep. Oh, that's actually a very solid policy. Holy, look at the exploration. It doesn't have perfect memory, but it does. There's just this getting like stuck thing. Okay. Yeah, that's crazy good. It does get stuck in weird ways occasionally. This is bizarre. In particular. I'm gonna put Aaron on that maybe. What are the clip coefs for this? So wait, this importance thing. We clip the importance weight. I can do like 0 to 5 uniform, right? Now you have all your priority coefficients. This up with gamma lambda. IO. Not sweep. Oh yeah, was it one update epoch? That could totally be it, right? Update epochs. 1, okay. That's not it. Okay, so we're gonna go to this box now and we're gonna sweep. We're gonna sweep grid, I believe. Total time steps goes to 550 mil to 600 mil. Batch size. Do I have this on sweep or not? BPT Horizon gets swept. The batch size should be auto. Okay, so this is going to be puffer grid. Make sure that this solves. In the meantime, how's our breakout going? Already 29 experiments. Pretty good. We got 23 with, I don't know if these are full solve scores, but this is pretty decent looking. We're getting these shorter runs. Take a while to see. Okay, so that's 2 experiments launched. We've got a full sweep on maze. We've got the breakout speedrun update. That's kind of all we need to have running for now. If anybody needs me on the Discord, and then if not, we will probably get to working on one of the release blog posts for this. Just so we make a little bit of progress. I don't know why Discord's not opening. There it is. Weird. Well, nobody needs stuff, just dumb shit in chat. Really dumb shit in chat. Oh, that's funny. So restarting Discord closed my browser tabs. Yeah, that makes sense. Let me go get my Restream tab back. Cool. So we did this initial protein draft. I think we have this one for now. I don't want to polish this too much yet. Do we have any non-protein notes down here? No. We're gonna make next one. Do algo improvements, new M's, the highlight. I'm trying to think how I just like, how do I make these interesting and exciting in a way that it's not just like the obligatory release blog post, right? Plus the algo stuff can be pretty interesting. I'm trying to think what is the best claim I can make here. The most precise claim I can make here. It is kind of just better than PPO. I hate when spell check just doesn't recognize words. How many experiments do I have on Neptune? The Apple self-driving. Gigaflow. What did we do this on? Like summed advantage? It was like summed advantage. Advantage.abs. Sum, yeah. Forget how we sampled this. I think we did prioritized replay based on this. Yeah. This is probably going to be like below this will be like an image of like before and after, like a sweep or whatever. Oh, hey, Weston. God damn it. I didn't notice your message because this thing, I forgot it crashed my browser and it crashed my chat client. Let me grab this. Usually I do this so that I have this like just under where my camera is so I can actually see messages. Here we go. Why are you adding the restream bot? True message. Huh. The restream bot is a bot. It's like the restream bot is oh, does it relay? I don't think I have it set up to relay to other chats, but they do pop up on the screen. Does it? Hmm. They do pop up on the screen right here, though. Either way. I think it's platform specific. Like, I don't know if X receives messages from other platforms or not. You'll find the prioritize replay. We can correct this. Fully compensates for non-uniform probabilities if beta is 1. Where's alpha? There's an alpha term as well. Alpha 0 and beta 1. Excuse me. Anyways, they're taking a break. My env I was making because it got difficult, so I'm making Sudoku. I have no idea. I have no idea if Sudoku is easy or not, to be honest. The action space for that's going to be a pain in the ass. Do funny Matrix stuff. Rise of the Half Moon. What's this? Is this a card game? Do they just have random devs at Google that just like make these for the hell of it? What? Confused. Place your card. Phases or full moves. What? Was this an existing game or was this like some Googler was bored? That's funny. Yeah, I don't know. Huh. Weird. Sudoku is 1 to 9. I had to make action 0 to 8. And then just do action plus 1. I saved the action as 1 to 9. And didn't notice. Yeah, you'll do that. That's a common one. I've done it before as well. Do you think the same approach is practical? Wait, do you think the same approach is practical for a field like computer vision, or do you think it's the same approach of what? Prime, if you're the same guy from before here, I don't know what the question is. Like, the same approach for what is practical? This is pretty good. How deep do you think I'd have to make my neural net to be able to replicate a Sudoku algorithm? I'm assuming relatively deep. Doubt it. The bigger problem is the only thing that you're gonna have as an issue with Sudoku, it's the action space. Like, how the hell do you do the action space for Sudoku, right? I mean, isn't it? It's 9 by 9. No, it's not. It's 9 by 9 with 9 options each. So, like, the flat action space is almost 1,000 dimensional, right? What do you think the action space is, right? You have to be able to select a cell and then fill in a number on that cell. What do you mean you're not selecting? So you're just going through? Well, you can't do that, right? That's not how... Gotta go? Alright, we'll chat later. Muon, coaster kneeling prioritized. 1H param set. This is pretty good. Like, have you taken things into your own hands for RL research by building your own algorithms from scratch? Yeah. Do you think the same approach is practical in CV or a waste of time? I don't think CV is anywhere near as cursed as reinforcement learning is. Reinforcement learning, there was a kind of a unique opportunity here just because people were hard trolling on the engineering side, and they got the engineering side so horribly, horribly wrong that, like, there was this just massive, massive room for improvement. There's definitely cool stuff you can do in CV, and if you're good, like, obviously, I mean, I'm a big believer that anyone can really revolutionize a field if they're good enough, right? Like, single-handedly, you can make a huge impact. But there's not, like, the obvious same amount of opportunity as there would be in RL, and it wouldn't be the next thing I would go to look at. Yeah, I, like, specifically, I look for areas, right? I like to find problems where I see like a massive opportunity to change stuff and nobody's doing it, right? That's kind of what I did with RL. And like here, I haven't even gone that far into the algorithm changes yet, right? We really just have a few small changes and already we're doing this well. This is a nice short blog post, right? These don't need to be super long blog posts, right? I think that this covers, like, obviously each of these, there's going to be like an experiment or two for each of these. Hello to YouTube folks as well. I see we have a fair few people here. What I'm doing right now is I'm going back and forth between hyperparameter experiments for the next release. and working on the various different blog posts for all the different things that we've done. Puffer Advantage is quite nice. I think that this is like people are going to be happy with this overall. Let's see how the sweep is going. We've got 86 experiments here. And the best one is how long? See how long the best experiment is. 19-ish seconds, I think, for a full solve, it looks like. I think our best before this was 17, but we have more than 100 experiments left, so we'll see how much this improves. And then if I check mazes out, maze is not doing so hot, which is kind of weird. We'll have to check back in on why that is. I do remember mazes being like they took a while to sweep. So it could just be that. We'll keep checking back in on those though. So we did draft of these two articles. We will probably now do I could do CAPI draft, that's pretty easy. I'll be right back though. I'm gonna go use the restroom and do a couple quick sets. And then yeah, I'll have another couple of hours to work on this still. Be right back. All right. All right. We do Quixie API blog post. I think this will be the one that people care the least about. But well, I don't want to do a blog post that people aren't going to care about. Let me see if there's anything cool either to do instead of this one or a way that people would find this interesting. Building fast sims fast. I think this would be... I think we can actually maybe get something out of this. Building fast sims fast, right? If I do like the Puffer C API, nobody cares. But if it's like building fast sims fast, like how we build fast sims fast or something, I think we can do something with this. This release includes an improved way of connecting C environments to Python. Yeah, but the thing is, I don't think anybody gives a shit about that, right? Is the thing. If I just write something like that, where it's like, that's like something you put in like release notes, right? I don't think that gets anyone excited. Right, I want like... So, I mean, I kind of have to think of this stuff like, this is not just meant to be docs, right? It's kind of interesting now that it's sort of my job to do a little bit of the marketing for Puffer as well. And like definitely like if you don't want to think of it as marketing, you think of it as like how do we grow the project in the library. So it's like, you know, what type of stuff can I write that will get people interested in trying out Puffer, using Puffer, and seeing all the stuff we built. And like that means not just playing to the existing base. So like you'll see that in some of the articles, right? I'll like explain what something like a standard thing in RL is. I'll give like a 2-sentence on what it is, but really simple. Like I try to do more things to bring people into it. Now I don't go to the length of like, I don't really try to market stuff to people who just like aren't going to be interested by any means, right? I don't try to like convince people to be interested, but there are people who are like, if they thought that they could get good at this and like do cool work, if they put in effort, they would put in effort. And those are the people I'm interested in getting on to see our stuff. I don't like that opening. I don't even like this intro heading. I think we do bottom up here. It's like I have to think of these things like so differently from how I normally would. It's kind of fun, to be honest. I actually kind of enjoy doing some of this type of writing myself because, like, one thing that really annoys the hell out of me is when marketing people will, like, oh yeah, let's sell it. The best way to sell about it is just to, like, fucking lie, basically. Just completely misrepresent what the thing is. So it's interesting to me to, like, how do I accurately represent what it is that we do while actually telling you what it does? Yeah, it turns out it's really easy to market stuff if you just fucking lie, right? It's like we discovered LLMs are really persuasive if they lie. Was the recent research? It's like, yep. What are your thoughts on guy I've never heard of latest tweets? Who's this? Huh? None of that's true. Yeah, I have no idea who this guy is. I don't think... Is this... I don't even think... Is this an RL guy? I think he's just like... Yeah, no, this is just some random dude. I don't know. You don't need a fucking 100-page RL book, is the thing, to learn RL. You just need to start doing something. Though I probably will sometime soon. I've literally never read the Sutton and Bardo book. In fact, I've never read a single textbook in AI, ML, RL. I've never read a single textbook in any of these. Like, some people just like textbooks, which is cool and all. But you can kind of also just start building shit. Yeah, but Yam's kind of gone crazy lately. Brilliant guy, but he's gone kind of crazy. Carpathy is brilliant. Carpathy is a funny dude in the sense that, like, he has some, like, brilliant insights, and then he also has some, like, absolutely awful takes on stuff. It's pretty funny. I was interning in Feifei's lab as a high school student with Justin while Andre was still there doing his PhD. It was pretty cool. I have some funny little stories on that. Yeah. Well, the thing is, like, I probably wasn't good enough back then to appreciate it. I was a fucking awful programmer. I was like 16 or 17. I was an awful, awful programmer. Like, holy hell was I bad. Like, dude, you've never seen some of the code. I wrote, like, I didn't know what a graph was or what a tree was. So I wrote, like, a 13 deep, like, a nested function recursive nightmare to try to process a graph without knowing what a graph was and without knowing what BFS was, all right? I had some awful, awful code. I was, like, by no means a natural. Yeah, exactly. That's how you learn, right? Dude, there is, like, so much stuff that, like, there's so much just basic stuff that you would expect somebody with my background to know that I just have no idea of, like, at all. And it's like, I don't know, but whatever. It's like, I'm still here and I'm still getting done pretty awesome stuff. How are you able to connect with these people and convince them to let you work with them? I cold emailed Feifei in like 2016. I cold emailed Andrew Ng and I cold emailed Feifei. Andrew didn't reply. Like, Andrew Ng didn't reply and Feifei did. To be fair, I had, like, there was a high school research program, so, like, you know, my teacher also sent a thing like, hey, you know, we have this research program. We've been scientifically training these students for the last year to hopefully do something kind of useful. So, I mean, it wasn't just like a cold email out of nothing, but it was still pretty darn good. God, it's kind of crazy to think back though on that and like I honestly couldn't tell you if it was just like why it took me so long to become even baseline competent. I honestly like looking back, I can't tell you if it was I mean, it was probably a combination of like programming is really hard. Programming is taught absolutely terrible. Like almost everything that's taught to you in a formal curriculum is the exact opposite of what you should be doing. Um I wasn't just devoted to that. It's not like college or even after where you have like a big chunk of time to devote to getting good at a specific thing. I was like massively, massively sleep deprived, trying to juggle a billion things. And I don't know. Maybe at that age you're just stupid as well. I don't fricking know. But you get there eventually. ML programming, yeah. I've never worked harder than I did in high school. 12 and 7, man, I was sleeping at like 2 and waking up at 7. Ugh, if I was lucky. I think I averaged like 110 hours a week for my last couple years of high school. It was awful. Yeah, it was just freaking awful. I think I probably did like 90 hours a week for a decent chunk of undergrad. I never did triple digits though after that. I never did triple digits after high school. And you can't either. Like, you can only do that when you're doing brain dead work. Brain just does not do anything that requires any amount of intelligence at some point. Weston, I get like minimum 8 or 9 hours. Like, I get 8 hours minimum and usually nine now. Like, you just do not compromise on sleep at all. It's like the dumbest possible thing to compromise on. Like, you have to because you're forced to when you're in like the strict structure of a school program and like, I was trying to get into college and all that, right? But afterwards, it's the dumbest possible thing to compromise on. And it's tough because like I wouldn't have told myself back then, I wouldn't tell younger me go get more sleep because like if I did, I wouldn't have been able to get done all the things I needed to get done, right? But like it's just rough. Why even have Malik or Kalik? Uh, no. So you allocate. I'm calling it static memory because I'm allocating once up front. It is technically Malik, and that's because you can't put everything on the stack. The stack is not infinite. The stack is pretty small. Stack is very small indeed. Speaking of which, article here. Yep, that's also true. Well, you can still put stuff on the stack at runtime, right? Like, you can still, I mean, that's what I meant, right? Like, yeah, you can pre-allocate some stuff, but, like, yes, that you can do however big you want, but then, like, you need to know how much memory you need afterwards. I guess technically you could just give yourself a giant buffer to work with at the start, but that's pretty dumb. Malik once up front is fine. Malik isn't evil. Welcome to all the YouTube and Twitch folks. We're kind of chatting and researching this and that at the moment, but also I'm working on blog post for the next release, currently on our how we make our environments super fast and simple. And then also periodically we are checking these experiments. Oh, there you go. Look at that. So like the sweep wasn't doing very well before, and now look, it just keeps going up and up and up like this. I bet this is just learning rate or something. There's got to be like some dumb parameter that just takes a while to optimize. Do you suggest course, wait, Tessera University of Alberta? I can't recommend a course that I don't know anything about, right? I I have a very basic quick start guide on my website that gives you blogs and papers that you should look at. It assumes that you have a basic knowledge of ML in general. So the only course I actually will consistently recommend is CS231N for deep learning basics. And then from there, you probably like need to start building things, reading papers and building things. Is it possible to use Puffer to solve a 2x2 Rubik's Cube? Well, yeah, of course. State space will be... No, it's not too large. RL solves way harder things than Rubik's Cubes. I'd be shocked if you couldn't do a 3x3 very, very easily. Andro Carpathy is really good. Yeah, he's very good. So Carpathy is very good. He has some good old blog posts on RL. The other really good person, and this is the blog post for this is in the quick start guide, which is on puffer.ai as well. Costa. Costa's amazing. Like, the reason that I'm here solving RL and it hasn't been solved yet is because Costa's doing language model stuff. Otherwise, he'd be doing it. Costa's awesome. Costa, C-O-S-T-A. He is the developer of CleanRL, which before CleanRL, all RL libraries sucked. After CleanRL, all RL libraries were still slow, but at least CleanRL was like simple and easy to use. 5 to 6 days of P100 to solve a 3x3. No. Those people have to be trolling. If you write a quick little, just write a quick Rubik's Cube environment and see, it's probably not that hard, right? If you at that guy on the Discord, he was actually trying to write one in NumPy or whatever. Like, you can probably write one pretty quick and see. If I want to be able to select cells, I would make the action 0 to 9 and make 0 skip the next cell. What? No, dude, because then you have to take frickin', like, if you want to get to the last cell, you have to take 80 skip actions in a row. He's talking about Rubik's Cubes. Okay, look. Weston, if you actually want me to give you, like, a reasonable way to do this that won't suck, like, this is what you do, okay? You make the action space discrete. You make it 0 through 8 or 1 through 9, whatever, okay? Action 1 selects which tile, you know, because it's 3x3 of 3x3s, so it selects which tile you're going to fill in, okay? And then the next action selects which individual cell in that tile you're going to fill in, and then the last action selects the number. And you can do that either as a three-way multi-discrete, or you can do it as a sequence of 3 actions. Try both. That's how I did the market system for neural MMO. Like, I just kind of imagined one really useful thing to do in RL is just imagine your problem if your problem were, like, on a Game Boy or something, or, like, had to be played on, like, a numpad. Like, how would you design the UI? And then just build it that way. There. That'll actually solve it for you. That'll be super easy. And then you just have to include in the observation space, right? The observation space probably just has to include, like, what cell you're looking at or whatever. Or your last action. That would also do it. Yeah, do that. That's super easy. Cellular went kaput. So what you do here is you do... Okay, like, let's just say that you're going to make your move a sequence of 3 actions. So first, 0 through 8, you select which 3x3 cell you're going to write into. Move 2 is which of the individual ones within that 3x3 block you're going to write to. And then finally, you select the number to write to the cell. Do that. Then it will actually work. You will be able to solve it very quickly. Amit, if you get that environment done, we will absolutely take a PR of a Rubik's Cube environment and see as well. We would be happy to have that. That's actually really easy to render in 3D as well. You would literally just render, what is it, 3x3x3, 27 cubes? Yeah, that's like, that's probably 20 lines in Raylib to just, like, render the cubes. And it'll look pretty good. I'm always afraid I get like ticks running outside. There are a ton of them around, and Lyme is no joke. Like anything itches, it's like, is that a bug bite or a tick? Pretty good. Pretty decent. Quick little article. I don't think if there's anything else that makes a big difference. Okay. Decent little article prototype. You see, chatbot. I saw they've been doing decentralized RL stuff. I don't know. I have a chat. I have a like a group chat that has a bunch of those people in it. But like RL for language models really isn't remotely the same as RL in the capacity that we're doing it. RL on LLMs is like dramatically easier in some ways algorithmically, and then just like and then really the only annoying thing with it is just like everything's incredibly expensive to run, and like it kind of breaks a little bit of their standard distributed infrastructure. So it's like a pretty different problem space. Why do you think the focus is on LLM RL mostly? Because of money? Because LLMs are the shiny thing right now. And like everybody goes and does the shiny thing. It's massively overinvested. Like, don't get me wrong, it's great. Like, LLMs are cool, LLMRL is cool, but it should be like 80-85% of the investment right now, not 99. Which is like, I guess another way of saying that is everything outside of LLMs is like order of magnitude underinvested at the moment, at least. Notoriously like OpenBSD. OpenBSD is cool. They got a puffer. I mean, the thing is like, I'll believe it when I see it, right? But like right now, LLMs generate absolutely garbage code. So the thing is, it's like code style is not just, it's not just do I use tabs or spaces or whatever, right? It's a lot more. Like refactoring things cleanly is a lot more than that. And it's like, I mean, that's not the easiest part of the job or anything. That's something that's like very few people are actually good at. So like, why would I expect that an LLM that can't do crap correctly is going to be able to do that well? Like, LLMs ain't touching my code until they don't suck at coding. But I don't want boilerplate. That's the thing, right? You don't want boilerplate. You want minimal boilerplate, and you don't want to press tab. You want to fucking sit there and look at your boilerplate and feel bad about it for several hours until you figure out how to make there be less of it. Put a print statement. Well, yeah, that's easy, and I have Super Maven for that. I like Super Maven, though, because it's like, it's mostly I do for like single line autocomplete. It's not like, oh, you need an AI code editor. It's AI for, it's just like, no, I want a typing buff, right? Like, lets you type the obvious shit faster and get out of my way the rest of the time. Yeah, I know it was bought by Cursor. It wasn't developed by them originally, and I'm hoping they don't ruin it. Because honestly, like, oh, man, so much garbage code is coming out of just people pressing tab and Cursor right now. Like, I'm not a fan of it. Well, yeah, that's just not actually coding, right? I have all the keywords around that stuff muted on X because it's just like, okay, whatever. People found yet another excuse to not put in any work and pretend that they know things. Whoop-de-dee-doo, right? Like, honestly, the way I run Puffer, right, is like I will engage with and help with anybody who actually gives a shit. Like, if people are actually at least trying to learn stuff and like trying to improve things, right? Like, you can get good at a lot just doing that if you're like at all clever. Um, the people who just don't care and just want to do stuff the dumb way and like not like, I just don't engage with them at all. Choosing what to learn. That's just what do you want to do, right? For me, it's like I saw this unique opportunity with reinforcement learning where I saw the potential of the field in 2019. I saw all the stuff that could happen with it. And then everybody just went out and started chasing the shiny thing with LLMs and stopped doing it. And I'm still here like, well, I can massively fix this entire thing single handedly. And I can revolutionize this entire field of science, which is going to trickle down to so many different areas of tech. Like, this is going to be a massive contribution. I can probably build a decent company out of it at the same time. Like, I'd be crazy not to do this. I'd either be crazy or wildly unambitious not to do this. Thank you. I mean, the thing is, like, at least on the research side, we clearly are. RL is not the same field as a year ago because of PufferLib. Like, do any RL outside of PufferLib or any RL a year ago and compare to what you can do in PufferLib now, and it's a different field. Well, thank you. We appreciate the contributions. We do appreciate the contributions. So I got this one, and this one drafted. We need this one to be drafted, and we need the new M ones. This one's super easy. It just needs a lot of graphics, which is annoying. I could take a stab at the highlight article, right? I got like what, an hour 20-ish before I gotta go. Maybe a little longer. I think take a stab at the highlight article. I go jam some experiments, and then we go from there. I'll be back in a couple minutes here. I gotta think if this is gonna be Puffer 2.5 or Puffer 3.0. Don't know yet. Take a stab at the new article. I don't know about 2.5.3.0. We'll put it as 2.5 for now, and we'll decide whether we how we version it. I honestly think it's probably safer to do 3.0 because, like, yeah. I mean, that's how versioning is supposed to work anyways. If every version is a major, every version's breaking. and figure out where I want to use. I had to workshop this bit a little bit. This is gonna have to be workshopped. So this should just be cool demos, basically, this article. This is kind of a bit much because we still tune. I think what are like the best, what are the coolest things I can show in this this release? Some random sweep plot. People do tend to like the sweep plots. So get a hyperparam sweep plot. Is it 6 new ones? Yes. No, it's 8 new environments. See how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 20. It's not quite a standalone like Clean RL is, I guess. Pretty close. think something like this is decent. This needs to be workshopped. I'm gonna need like a few nice taglines for the release. Look at my current website. Yeah, this MOBA looks so freaking cool. I like our website. This is actually not bad. I think I'm gonna have to like think through this more, but this is not bad. This is like a good start on a bunch of articles, right? I've got 4 of these. I still have to write the environment one. They'll all have to be edited. 1700. The protein one's big. Algorithm one's pretty short. This one's very short. Just a quick intro. So we'll do like this one, then this one, then like this one, and like we'll spread them out nicely. We'll spread them out very nicely. Okay, so this is like surprisingly not working, right? We'll let it keep going, but there's something very weird there. And then, what about this? Is this still going? Yeah, this is still going. Oh, this is interesting. So this one here. What happened to this one? Yeah, this is a solve. But I don't know if this one's lucky or what, but this is a 17-second solve right here. So this is going to have like a whole bunch of additional trials to see if it can replicate this. Yeah, 17. I guess it just doesn't run the full evals on this. This is Breakout. We're trying to speed run Breakout. Yeah. Basically, this is just like, it's kind of a showcase. It's kind of for fun. It's just how fast can we solve Breakout. It's pretty good. Undergrad in CSC. EC. Computer Science and Engineering. I don't know what ECE is. Math. Do what you're interested in and like what the field you want to work in is. Like if you hate building stuff, you're not going to have a good time spending a bunch of time trying to figure out how to program better. If you hate math, you're not going to have a fun time doing a bunch of math and you're not going to be good at it. Like pick something that genuinely interests you. Electronics and Communication Engineering. Yeah, we don't have any of those, like, I don't know where this is. The US, it's like it's computer science, electrical engineering, math. And I have no idea what your curriculum, like what your stuff looks like. Like in the US, it's like you take some courses and then you probably better be doing some cool stuff on the side because, like, congratulations, your courses qualify you to do exactly nothing when you graduate. You're doing something similar to the Fast GPT. What? What plasma? Oh yeah, that. Yeah, exactly. In fact, I got some of the techniques from that and just like threw them on RL. Oh, this is insane. Huh. It did the crazy value function clipping thing. Minimum possible value function clipping coefficient. It's nutty. You have a general suggestion on how to minimize conditional branches. I feel like I have to use them constantly in my game, man. What's wrong with conditional branches? That's like a core component of programming. There's nothing wrong with conditional branching. Conditional branching is only a problem if you're trying to run stuff on pure GPU. And like, RMs are not written for pure GPU. They run on CPU. There's nothing wrong with branching. Okay, so this is Pareto Frontier. I guess we just do time less than 25. Filter. What the heck is wrong with these filters? I guess we just do this. Okay, so this gives us something. So this sample here, we have a learning rate region here, right? Got a gamma region here. Lambda. I'm just looking for like weird stuff. X gradient norm. Entropy. Couple different mini batch sizes. Oh geez, these are crazy fast, some of them. So it is actually sweeping really high perf stuff if we're training over 5 million SPS. We got atom beta. That's pretty tight region. Priodors to alpha, prio beta. Beta doesn't seem to matter very much. Alpha does though. And then what was the where's VF clip coefficient? I mean, I would like question why you're thinking about minimizing branching in the first place. There's nothing wrong with branching. Right? You want to minimize complexity. Complexity and branching are not the same thing. Okay, so we have generous clip coefficient and a lot of like very low value function clip coefficients, interestingly. Well, yeah, unnecessary branching, right? But generally, proxy things are bad. Like, you don't want to look at your code and be like, dang, how do I minimize branching, right? You want to think holistically about complexity. Like, really deep nesting is often an indicator that something is done wrong, not always. Having a ton of functions is often an indicator. Like, overly split up stuff is often an indicator stuff is bad. Basically, anytime I open a repository that has like 20 files that are 100 lines each, I can guarantee that I can rewrite it in like 2 files that are, 400 lines each. Interesting here, this one is so much better. This could just be a lucky seed, I guess. I doubt it, though. So this is this, like, dark maroonish one, I guess. I guess we can see... Where is it? Where the heck is my... There they are. Okay, so it's this one here, 29,326. Got a pretty high learning rate. Trying to see like what it is this does differently. Not this. Not really this either. Let's see. Oops, 1 second. Well, this is creation time, so this doesn't matter. Mini batch size? Okay, it is one of the few with higher mini batch size. In fact, it's the only one with high mini batch size that's managed to do well. So this is going to make it faster. Wait, do we have total time steps? Okay, so it is the highest total time steps run that is good. But then where's the SPS? Okay, it's like decently fast. This one is faster. What's this? 29,184? Is this right? Something seems off there, doesn't it? Okay. 29. We have here. Yeah, so this is 29,184. And 29,184 looks like this. It takes 22 seconds. But it has almost 7 million SPS. Huh? That doesn't match up. Because it's only trained for 53 million steps. So this should be done in less than 10 seconds. Right? So clearly something is wrong here. The moment. Any dang flies. Alright. I mean, so this seems weird, right? If we have 7 million SPS, I kind of want to grab these params. Why do you have so many files? Where? Flies? Oh. Because it's a warehouse, and we have 10-foot garage doors, and we keep having to open them in order to deliver gym equipment. Plus, there are other people here doing maintenance because the building's not fully finished. Like, I don't have hot water here yet. Well, yeah, we are actually, we're getting screens for some of it, but they're not here yet. I don't know, I've killed like 30 flies here just in front of my window. Man, that's like that's not even in the new ones, right? That's like a super old reference. I'm gonna try these. So am I. Two M's. Let's see if we can figure out why breakout is weird. It's a good thing to do right now. Well, something screwy that this is logging 7 million SPS, right? Oh, it's probably just logging SPS wrong, right? Yeah, because that's like a 20, 30. Yeah, that's a reasonable time to take. Self.sps. CPU, how can it be bigger? Because it's per core. If you're using 2 cores to full, it's 200. So, I mean, this seems like it should log correctly, but I guess not. No, this does log correctly. This totally logs correctly, which is weird. It's very weird. Okay, so that's suspicious then, right? That we have like these ridiculously high SPS values. Hang on, do I have like num-ems wrong or something? Could that be a thing? Batch size. This is auto. Alright. Is there like a num-ems on here? Oh, that's not the one I want. I'd have to have like back. Something screwy here. So vec has num-ems, right? Sweep.vec.num-ems. I wonder if this is just like not getting logged. If I click this thing. So this is 2. But does it actually log this? this does append args here, right? What about experiment? So Neptune logs everything. Unroll nested dict. So hang on, shouldn't this then give me... This should do like train slash or train dot. Probably train slash or vec slash. Vec slash numems. So like, I just go here. Okay, so here we go. We have this. And it's all on 2. So it is sweeping this, but it's all on 2. That's not it. I think it's just reporting SPS wrong. Oh, you know what? It's reporting inference SPS. That's what it is. Because it reports the last point for SPS. So I bet you I know if we just do like... Yeah, there you go. See? Inference SPS at the end. So practically we're training between like 2 and 5 mil SPS, which is what we would expect from this. We could go much faster. What about update epochs? What? Wait, 4? Are we all on 4 update epochs? No, that's max. So do we have update epochs? 1. Oh, but this is just the best runs are 1 update epoch, right? So like... If I go here now... They're still mostly on 1. How about numems? Okay, I mean, there's a little bit of exploration, maybe. I mean, so now we know the time estimates are mostly accurate, right? The YOLO value function coefficient thing is kind of nuts. But we've seen that quite consistently. Where's the Pareto front for this? Not it. I just want to make sure I'm not missing any like major opportunities here for this to be bigger. Let me see what this this crazy one was. No, it's not this one. Yeah, so this is the one that we were looking at. So this is 66 mil steps. So this says 26 seconds. So we're not matching just on raw speed, I think, here. So this is on the slower machine. We can get SPS on this. Oh, this says that it's supposed to run at 4 mil. That's kind of weird, right? Did I miss something? I feel like I must have missed something for it to be running this fast. It says Vecnum EMS is 2. I feel like I missed something. To be running that fast? I mean, this does repro. It just doesn't repro the speed. I'm pretty sure I'm logging. Like batch size, or is it autoed? Autoed. Is it like this or something? That still doesn't give you 4 mil. Because that's kind of weird. Mini batch, maybe? No. Oh, mini batch I missed. I missed the mini batch size. There, that's it. Okay, so that's like up to 3 mil. We don't get our eval. Hang on. This is a vec env async reset. And then this has to do print dashboard. It doesn't seem to do it, right? Time, so 7:48. Yeah, this is 7:48, so this does not, I mean, I could believe that it's like, it got a lucky run, but it's not gonna consistently solve for you. I also don't know where this thing is 4 million SPS. Could just be the other chip. Files off. Hmm. Yeah, it is. It's a little luck dependent, you can see. Then 5 mil SPS for eval. Well, that's one of the things that's a little tricky with running a sweep, right? Is naturally also the best runs are going to be the luckiest runs. So you generally what happens is that the runs do they do roughly the same, but if you're on a speed run budget, right? Like, let's say you get 10% lucky, right? You get like a better seed, it could train like 10% faster or something. So you'd have to add like 10% steps to make up for it. Like this one here, right? Like this curve could be shifted over a little to the right. So it's not like the params don't work, they do work. But there's a bit of variability. Like this is a 20-second run right here. A little weird to me that we haven't found any like really high perf stuff. Randomly initial weights. Sure, like you could attribute it to that, sure. Well, I mean, it's like the random weights affect the data that you get, right? So you're actually, your weights affect your data distribution in RL. Which is why it's a sure, not a yes. $151. Well, we will let this finish. Something happened with these mazes. I bet it's stuck on like bad VF clip coefficient. Let me see. I bet it's like stuck on bad VF clip. Yeah, you see it's like, I guess I need sweep progress. It's almost certainly stuck on bad VF clip. Clip function for, it's a clipping coefficient for the value function. There's this weird thing where you can have like these YOLO runs that set it really low and still somehow work. No, it's the clipping for the reward function loss. Value function learns to predict the advantage function, which is computed based on the reward. Maze run is not very good. Value function similar to cost. I mean, supervised learning, you often you have like one loss, so like not really. Because you have two losses at least in RL. Well, it is an MSE loss, but it's MSE over the prediction of reward, which is quite different from MSE over prediction of raw outputs or whatever, or like of like a known variable. Prediction of returns, I should say. I'm trying to think what to do about this. On one hand, like, Kinda want to play with some of the values. Or chain of what? What chain of derivatives? Value function learns to predict return. Return is given by generalized advantage estimation or in our case puffer advantage, which is GAE plus V trace. Well, chain rule is just applied everywhere for like backprop in general, right? There's nothing special. I'm just trying to make some good decisions here on like what I should run for these sweeps. I gotta go soon as well. To be fair, I'm probably just gonna come back and launch these after dinner anyway, so I let these finish. What was the value function clip in PPO? EF coefficient? It's just clip coefficient that they use, right? V loss clipped. Clip coef. Which is like 0.2 or whatever. 0.2. And like if I go look at, let me do one last thing here that's kind of important. If I like do this, I should do you've got one run out here. Why the hell does it do this is what I want to know. I gotta figure out what the hell that even does to the policy. Bizarre. Well, I'm gonna call it. I'm gonna go, I gotta go do some stuff. Then I gotta get dinner. I go out for dinner today. And, I'll probably be back in the evening for a little bit. We will see. But I do want to get these sweeps done. So for the folks watching here, Puffer.ai for all the things. It's all free and open source. If you want to help me out for free, start the repo. And if you want to get involved with development, join the Discord. You can also follow me on X for some periodic reinforcement learning content. So thank you, and I'll be back in a bit.